Hello, everyone, and welcome to this webinar. Let's wait a few minutes until everyone join, and then we can start fully this webinar. Thank you for your patience. And while we're waiting for more people to join, I would like to talk about our event in Madrid and Pulse. About Pulse, it's going to be in Madrid on the 3rd and 4th of April. It's our renewable energy conference, and obviously it's back for its third edition in 2025. Super early bird tickets are now available on the website with 50% off until February. And obviously, this is a great opportunity to purchase a ticket if you're considering attending. Um, so yeah, I think this is a great opportunity to do some networking, to discover new updates about RatedPower, the new obviously to also get an insight on future product updates, everything that we're planning to do. And obviously it's a great I think it's, as I said, it's a great opportunity to get to meet all of you, and obviously to do some good networking.
Yes, absolutely. We every year would prepare a lot of insightful workshops. It's not only about rated power, it's also from a lot of other resources. For example, our users would come and speak about their updates on the industry, different technologies they envision in the future of our energy sector. And also, our parent company, Inverters, would be presenting on this event as well. And they're going to share some insight about what's happening in the US and also globally, how they look at this sector. So, welcome to join Pose and hope you can get a discounted ticket very soon. Hope we could see you there.
Thank you, Ming.
Thank you. We're seeing more and more people joining at the
Yes.
moment. I see more people than when I conducted a webinar last year. I don't know if it's because we have shared the webinar information on the Rated Power platform in the notification. I think it's a great tool where you can actually gather and see all the recent activities of our company, our team, and the software itself. And if you notice, today there was a new post. There is going to be a scheduled maintenance on Thursday this week. So that's going to be tomorrow in Central European time, starting at 8 a.m. and it's going to take up to 1 hour. Thank you in advance for your understanding. If there's anything happening during that hour, a small shutdown or a glitch on the web page of Rated Power, do not feel surprised.
Thank you, Ming. Perfect. So I think we can start right away. So, welcome all to this webinar. I'm Samih and this is Ming. We're going to be talking about how to unlock the full potential of your East-West PV designs. Obviously, it's a super important topic that we're going to check out together. I'm Samih. I'm a technical advisor. I have over 3 years of experience in the renewable energy industry, and obviously my main points of interest are how to improve the industry and from a technological and innovation point of view. And obviously, we all thrive to develop the adoption and the development of this incredible industry.
Um, then it's me, I'm Ming, and I'm the technical advisor for Rated Power as well. I have been working here for almost 3 years with a combined 6 years or 7 years of the working experience in this industry. And I have been working closely with Japan, China, and Oceania regions. And yeah, today we are bringing you the exciting topic of east-west facing structures. And let's stay tuned.
Perfect. So, what are we going to be seeing today? So, first of all, my colleague Ming is going to do a quick introduction onto what are the east-west structures. Then I'm going to be taking a look at what is the MPPT and how it works, obviously, because it is a also super interesting topic. After that, I'm also going to open rated power, and we're going to get through the software together. We're going to see how it works exactly with east-west structures and the MPPT configuration. And finally, me and Ming, we're going to be answering some questions that all of you write in the chat. Obviously, we're going to be reading them and answering them together and checking them out together. So let's get started. I'm going to give the microphone to my colleague Ming, and she's going to first of all, well, give you a quick introduction into east-west structures.
Yes, thank you, Samih, for hosting it. Let me start by introducing what is it, the east-west facing structures. I'm sure that the audience don't find this technology novel anymore. We have been hearing about them in the recent years more and more. The technology is really picking up. So the east-west facing structures are like illustrated in these images with solar panels installed with half of them facing the east and half of them facing the west. And in the middle center pictures, there is a small green arrow. This represents for the ridge distance. So the two rows of the structures are going to be either hinged or clamped together. And the installation of our east-west facing structures can be either mounted on ballasts, like the first image is showing, or clamped onto the piles, just like the center image, or some manufacturers even pre-assemble them in the factory so that installers, constructors, can easily roll them out on the site without having to drilling the piles one by one as the old days, or even require more heavy machines. So these are how the east-west facing structures are like. They are now more prevalent in Northern Europe with high latitude countries. We see them a lot in Oceania region as well. And as the third image is showing, it's also quite popular for CNI solutions in on the rooftops. So now let's talk about why it has been favored by the industry in the recent years. For east-west facing structure, is it really better compared with the traditional fixed structures? Where our modules are fixed towards the equator. So on northern hemisphere, they're facing the south, where we can extract the maximum sunlight, and on the southern hemisphere, vice versa. For east-west facing structures, instead of facing the south or the north, they're facing east and west. And these are some advantages that we actually observe compared with the traditional fixed structures. First, it's really nice to be utilized on limited space and rooftops that we can add more structures there, meaning more capacities. And compared with the traditional fixed structures, the east-west facing structure has a more flat production curve. It has more advantages on energy performance, such as a potential of lowering the temperature loss or optimizing with the MPPT solution that Samih will introduce in the second chapter. And on the cost side, we have cheaper design, cheaper logistics, material, labor costs, etc. Makes it a whole cheaper capex package. And finally, with the triangle shape of the structure, we have reduced the wind loads on the structures, making them stronger than the traditional ones. Now let's dive into more details of the advantages that I have explained in this slide. First, regarding the land, we know that there's a rapid increase in land costs, and mostly in countries such as Northern European countries or in New Zealand. And this means that in a more limited or more challenging terrain, we want to squeeze into more structures to bring up our capacity and on DC side. sometimes with a higher DC ratio. And on the countries with higher latitude, we know that because the sun azimuth requires larger pitch distance, no matter it's fixed structures or trackers, in order to get the best out of the sites, we want to also make sure that we are exploiting the drop of the module price and increasing the DC capacity there. And the third one would be the energy performance. So we all know that nowadays we have mismatching of the supply of solar energy with the actual demand, and it's a famous duck curve. This is causing the market price of solar energy to fall sharply, and this in turn cannibalizes its own profits. So, Samih, if you click again, we will show the curve of the duck curve. Here you can see it's a graph of the power generation over the course of a day. And the imbalance between the peak demand and the solar peak generation occurs. And during the midday, we have lower of the demand, but the maximum of our solar generation. And in the evening time or the later afternoon, when plotted on the graph on this curve, we see the demand is much higher, but we barely have any generation from the solar. Okay, so next slides we will explain with the combined advantages of cheaper capex, stronger structures, and also an optimized energy performance with MPPT solution. With all these advantages combined, this brings us a better solution for those scenarios of higher latitude or limited land, challenging land, to give us with these west-facing structure. So now in the next chapters, let me show you how the energy curve is behaving between fixed structures and east-west facing structures. So this is quite familiar to all of us. As a normal fixed structure, we're having the spike of the supply at the midday. And if we're using east-west facing structures, in the next slide, you will see with a east-facing structure, of course, the tilt is not the most optimal facing the south, so that we're getting in total lower energy production, and the spike is going to be in the morning hours. And with the structures facing west, we're collecting more sunlight and energy in the afternoon hours. If we combine these two, we're going to end up with a flatter curve of energy production. And comparing this with the traditional fixed one in the next slide, we will see that the east-west facing structures will produce energy at a more stable rate throughout the day. And this can furthermore reduce the chances of inverter becoming overloaded by the midday spike. And now I have explained all the advantages of east-west facing structure and what is it and what situations are more popular for these technologies. I have also done some case studies, and today I'm showing you a solution that I have replicated on a rooftop. So this site, as you can see on the lower bottom right picture, is on a factory in Texas of the US. And the available area for the entire rooftop is going to be 8.6 hectare. Because it's located on the rooftop, we might want to consider some different criteria from when we're designing the ground-mounted one. For example, we want to make sure we have maintenance corridors on the rooftop for mostly human beings instead of heavy machines. And we also want to have optimal block designs so that we have more optimized LV cable and string inverter distribution for the energy production. And also for the piles, we want to make sure that they're not so long as ground mounted, but more closer to the ground. So on rated power, how I set up was pretty simple and straightforward. On top right, you will see first we want to select the structure as east-west facing structure with one P, so one structure vertically mounted for each orientation. And then I want to make sure that my mounting system is correct with tripole strategy and a lower clearance to the ground. And the 3D energy, 3D view of this site zoomed in would be the picture on the left side. So on the same factory rooftop, I have done also a traditional fixed structure scenario. In the next slide, you will see we have applied the same capacity for the PV installation. And I have compared both scenarios on rated power, and you can see on the top right image with the comparison results. First of all, with the peak power, we're getting 13.9 megawatt DC, so very similar both sides with the same amount of module. And um, if you click again on the slides, you will see we have some highlighted information. For example, the specific yield of east-west facing structure is going to be 29% higher. And the energy production per annum is 28.4% higher because we are, because we're having more of the energy sent to the grid from the inverter from the AC side. And then finally, for the PR, it's really incredible because we wanted to squeeze the same amount of structure for the fixed structure on the same size of the land. We are compromising the PR because the pitch distance is really not favorable. So now with east-west facing structure, we have 52.5% of higher PR on the same land. And if you have a look at the table that I have sorted out the figures, you will also observe, obviously, the bigger difference between the traditional fixed structures and east-west facing structures are higher on morning hours and afternoon hours. And this can be also seen on the energy production curves, where you will see not only the east-west facing structures having a flatter energy curve, but also it's going to be less variable across the year in different seasons. Unlike the fixed structures, from summer to winter, we're having completely different production curves. All right, so that was my comparison and case study on a rooftop solution. Next, I will give the floor back to Samia to explain what is MPPT and how it works.
Thank you so much, Ming. This really looked like super interesting technology. Honestly, I think this is really where I mean innovation and technology meet, obviously, to develop our sector, and I feel like this is something really to look forward to in the future. So now we're going to talk about what is MPPT and how it works, as you may have mentioned, Ming. So what is MPPT? MPPT, first of all, is a technology used in solar inverters to maximize the energy harvested from a solar PV array. You may ask yourself, how is that done? Well, it continuously monitors the voltage and current output of solar panels and adjusts the electrical load to keep the system operating at its maximum power point, or MPP. So why is MPPT necessary? Solar panels produce varying amounts of power based on sunlight intensity, temperature, shading, and other factors. Obviously, as Ming mentioned, we can have more energy in the morning than in the afternoon. It really depends on the meteorological conditions, the shading, and all of that. So obviously, their voltage and current characteristics are non-linear, meaning the power output isn't consistent. By using MPPT, the inverter can adapt to these fluctuations, finding the optimal balance between current and voltage to maximize the power output, obviously, under changing conditions. So, how MPPT works? The inverter MPPT algorithm measures the voltage and current from the panels and adjusts the operating point to match the system's MPP, where power obviously equals voltage times where power equal voltage times current is at its highest. So as you can see on this graph on the right side, we have the exact MPP, sorry, that we're going to be looking for, and obviously it is right in the middle, obviously, of my graph. It adjusts the load by modifying the inverter's internal parameters to achieve the best voltage and current combination, maximizing energy efficiency. So, what are the key benefits of MPPT? You may ask yourself. So, there's three main benefits of using MPPT. Well, first of all, it maximizes the efficiency of my inverter by ensuring that the solar system always operates at the optimal power level, even when conditions vary. It improves the yield in varying conditions. Second, it helps deliver better performance under partial shading, varying sunlight and temperature changes, obviously. And the third and foremost, it increases the energy output. It maximizes the amount of energy harvested, which obviously improves return on investment for solar installation, and obviously also affects the LCOE for that matter. So how to activate MPPT in rated power? We're going to check that out a bit later, hands-on, how to activate it in rated power. But for now, we have also included some screenshots on how to activate it in rated power. Well, it is very simple. The MPPT configuration options are only available when east-west structures are selected. You would need to choose this structure first and then go back to obviously equipment, inverter, MPPT configuration, and then we're going to be able to have these options. So if you're using a tracker or a fixed structure, this option unfortunately won't be available for you for now. The reason for this is because our energy model will consider a flat terrain and homogeneous irradiance, meaning that no difference will be computed in terms of energy in each of the different MPPT levels of that inverter. It would be like using an inverter with only one MPPT. As you can see on the right side, this is a screenshot that's taken directly from RatedPower. Each one of these MPPT options will give us different results in the energy yield analysis, and also we're going to check that out together. Speaking about energy yield analysis, we have many different losses that are related to the MPP that are taken into account in RatedPower, and obviously they are reflected in our energy yield methodology in the chapter 8. If you're curious to know that, this methodology will be linked in the description below. Well, these are the different electrical system losses that are reflected in the monthly values. We have four types of losses that are super important, obviously, due to the MPP outside the operating window. As you may already know, we need to keep that MPP inside the operating window to track it and to have the optimal MPP. So these are the four losses that are related to that MPP being outside the operation window. First one being the inverter voltage threshold, let's say on the left side, the inverter over voltage, the inverter power threshold, and the inverter power limit. All of those obviously are going to be related to that MPP, and we're going to try and avoid all of those losses and to take care of them. So I'm just going to open a rated power. I'm just going to open a rated power window, as you can see. So this is a typical scenario that we have in rated power. This is a fixed structure. This is a fixed structure project. If we click on structure, we're going to see indeed that this is a fixed structure. This project is located in the UK. I used it as an example because if you remember earlier, Ming mentioned that MPPT and East-West options are especially useful when selecting when doing a project in the northern hemisphere. So this is exactly what we did. Let's take a look first at the losses that we have here, and indeed we have some power limit losses that are due, if you remember, to the MPP being outside the operating window. So we're going to try and fix that. How do we fix that? Well, it is very simple. We just have to select here the east-west structures. We just have to select here, and then as you may notice, some MPPT options will deploy automatically in rated power. You don't have to do anything, and obviously we're going to have some different options to select from. So the first one being the single MPPT inverter, the second one being the multiple MPPT inverter, and the third one being the separate inverter. But before going into the MPPT configurations, I just want you to take a look at the power we have achieved by switching to east-west structures, because as Ming said, This can be super interesting and super important for your project. So as you can see, we have, if we go back to the design number 4, we have increased our power from 66 megawatt DC 55 AC to 154 megawatt DC and 129 megawatt EC. We have almost tripled our production. Obviously, this is super important, and obviously, this is going to affect our this is obviously going to affect our results and our numbers. So when we have selected the single MPPT and the east-west structures, we can see that indeed our inverter power limit loss is now gone. We have now avoided that power loss that was obviously not so insignificant because it was 0.50%. It is quite a lot considering that this is a big power plant. So obviously this is going to affect our specific production, our energy output, and all of that. So I have then selected these three options: the multiple MPPT inverter and the the separate inverter. So you may ask yourself, what are the differences between all three of these MPPT configurations? Well, it is very simple. Obviously, the single MPPT inverter means that both my east and west array will go to the same MPPT. The multiple MPPT inverters, well, as the name says, means that each one of the east and west array will go to a separate MPPT MPPT uh, box, let's say. And the third one, which is separate inverters, means that the east and west arrays will go to a separate inverter. Obviously, the main difference between these three options is in this case going to be cost. Obviously, having separate inverters for each different east and west area, it's going to be more costly, but obviously we're going to have a gain in our performance ratio, a gain in our specific production, and obviously the losses are going to be affected. So I'm going to also take this opportunity and check out our comparison tool. So I'm just going to go back and we're going to compare all these four projects. To be able to use our comparison tool, it is super simple. We just have to manually select all projects that we want to compare. Then we'll have an automatic button that is compare that's going to be deployed. Obviously, this is going to take us to our comparison tool. If you just click on it, our comparison tool is a great tool to use, especially when comparing for projects. We're going to have the fourth, the sixth, the seventh, and the eighth one. They're all going to be here. We're going to have all of these different filters to get to check out from, and obviously we're going to have even more filters, because if you click on filters here on the right side, another deployable filters area is going to be deployed, and here we're going to be able to select, for instance, the return on investment, for example, let's also check out the PR, performance ratio. It's going to be here, and let's click on apply, and now we're going to have even more filters. So let's remember the options that we have selected. The design number 4 was the one that we used only with fixed structures. The design number 6 was the one that we have where we have selected for the first time the east-west structures, and we have obviously selected the single MPPT. Design number 7 was the one we have selected multiple MPPT, and the number 8 where we have selected the separate MPPTs. So if we take a look at first of all, the LC or the if we take a look at the specific production, we're going to see that indeed the design with the the highest specific production is going to be the one with the fixed structures, but we also have to take a look at the energy production, and that is where we're going to have a big difference, because obviously the design with the highest energy production is going to be the one with the separate inverters. That's going to be the one that has the highest energy output, and it's also going to be the one that has the highest performance ratio, because if we go down here, we're going to indeed see that there's a big difference in the performance ratio every time we select a higher MPPT configuration. We're going to have a higher performance ratio, because obviously our project is going to be more efficient and the losses are going to be reduced. But at the same time, we also have to take a look at the LCOE, because obviously Obviously, by selecting the higher option, it is going to affect our LCOE, but not in the way you think. Because if we take a closer look at what we're doing, obviously the LCOE from fixed to east-west is a bit higher because obviously we're going to have more structures and the cost is going to rise. But every time we select a more advanced MPPT configuration, we're going to see that indeed the LCOE is going to go lower. So the LCOE is going to go down, even though we're selecting a more advanced MPPT configuration. So that's going to be something great, especially if we're looking to reduce the cost of the LCOE. And obviously, all of that is going to also affect the specific reduction because every time it is going to go up in all of my east-west structures, and also the active power is going to go up, and obviously the peak power is going to change a lot. We're going from 154 to 157 only by selecting separate inverters in east-west for MPPTs, and obviously that is quite the jump, 3 megawatt, and it is significant. So this is how the MPPT and the east-west configurations are going to affect directly our results in rated power. So yeah, now let's start the Q&A sessions. We're all ears, and of course, drop your
Yes.
questions in the box.
Yeah. So in conclusion, the comparison that Sami has just shown has a significant difference in the LCOE, which can help us to make a quick decision on which technology is the one to go for. But just remember, for this case, we did not take the labor cost for construction and OPEX into account. So the total cost for east-west facing structure in this case is significantly higher than the fixed structures. But remember, for the maintenance in the future, or even comparing the land cost, we are not taking that into consideration in this case. The total price might be even lower for east-west facing structure in that case. So the LCOE could change and become more lucrative. All right, so with the Q&A session, we've already received some questions. I'm going to read it out loud. First one is, since you're giving example on the rooftop, I guess the pitch distance wouldn't make such difference. Actually, I think that's regarding both our designs. So we have both made comparison between east-west facing structure and fixed structures. Although wherever it's built, either rooftop or ground mounted, we're always considering the near shading loss and area shading loss. So for example, my case where we're squeezing in the same amount of structures on the same size of land, we are having lower pitch distance for the traditional fixed structures, and that gives us an area shading up to 30% high. On the contrary, for east-west facing structure, for my case, the area shading was lower than 1%. So the pitch distance, it is going to influence a lot on our results of the energy specific yield and PR. All right. So the next question, I don't know if Sami, you can
Yeah,
see any of the questions. I'm gonna
yeah.
answer another one, and maybe you can go for the next one. So I will answer also, in which country would you say east-west facing structures are making the most sense and the most popular? My experience or knowledge is that in the countries with smaller lands, more challenging terrain, or
Hmm.
higher latitudes where they don't have favorable sunlight, so that they want to maybe make the DCC ratio higher to fully exploit the low price of modules nowadays and to generate more power compared with the traditional fixed structure or trackers. Those are the countries that we observe. So in the Northern European countries and New Zealand. And then we also see them in Australia because a manufacturer called 5B Maverick is pretty prevalent there. Also, another manufacturer called PEG, they are making a lot of east-west facing structures, and they are guaranteeing a lower cost for construction. So for the ease of construction, it's very attractive to the industries as well. And I would say in the Middle East, is rolling out of a lot east-west facing structures as well. I'm
Mhm.
not sure for which reason it is. Maybe it's also for a lower labor cost and future maintenance fee. It's becoming more prevalent there as well.
Thank
Do you
you.
have
Yeah.
anything? Yeah, go ahead,
No,
Samih.
I totally agree with what you said. I think, yeah, especially in the countries in Northern Hemisphere, where obviously land is a bit smaller and the sun is not as present in other countries, I think this could be a great option to really take take as much advantage of the land and the materials and the sun that you have. I think that's a great input. I'm gonna take the next question. So, can I design floating solar with this type of structure? So unfortunately, floating solar structures are not available yet in rated power. It is something that we have taken lots of feedback about, but it is still it's something that's not yet available in rated power.
Yeah.
Um,
Um,
I'm going to take also the next one. How do you replicate designs on rooftops with lots of objects on rated power? So if we want to have a design on a rooftop, we can do as my colleague Ming did, basically take any rooftop that you want. And for instance, if you have, for example, lots of small objects that you want to take into account in that same rooftop, you can, for instance, have some restricted areas or draw some shortcuts so that the software will take them into account.
yeah. Okay, so let me answer the next one. Is rated power working for rooftops smoothly? Because there was a limitation on using the software for any projects rather than ground-mounted one. I took today's chance to show you a solution on rooftop exactly because we have recently released a new feature called Layout Editor. So it's giving us much more flexibility when it comes to designing the layouts as we want. It includes different features and functionality over roads, power stations, and structures, etc. So as you saw, the solution I replicated on Rated Power is really good actually. It looks very similar to the rooftop solutions I see in the public on the internet. So maybe as a user of ours, you could go ahead and have a try to see if the results meet your requirements. Next one is how does bifacial gain compare across east-west facing structures? So for the bifacials, we are analyzing the bifacial structures the same with the same energy model. So the energy model for that part of the algorithm is not changing between east-west and the fixed structures. So what we observe is probably as the same to the front facing radiation because of the favored a near shading loss and area shading, we're observing better irradiation hitting the back face as well, therefore giving us more of the back face production. Also for the back face, we have a huge amount of diffuse irradiation that also contributes better in east-west facing structure because we're having a higher, a better iris shading or near shading there. All
I'm
right.
going to take the next one. So,
Yeah.
Samih mentioned to draw restricted areas when you have objects in rooftop. What about any shading from those objects? How is it considered? Thanks. So, that's a great question, and actually, the way rated power works is that any near objects, for instance, the power station, the trees, any for the barriers. Unfortunately, that kind of shading will not be taken into account into our energy yield analysis yet. It is something we are working on to implement our brand new 3D energy modeling. It is something we're working on, but currently the only shading that is taken into account in rated power, near shading that is taken into account in rated power, is obviously the inter-row shading between each one of the panels that are stacked together. That is the only shading that is taken into account. The rest of the shadings, such as the question said, well, objects, near objects, small objects that are next to the arrays, they're not taken into account yet. But it is something we're working on to implement very, very soon.
Absolutely. Just so the audience will know, we have been working on our own 3D energy model, which will take the objects and terrain into consideration for our 3D energy yield. And the question here could be addressed by that new release. Stay tuned for our updates in 2025.
Yes.
Next one I can take. We are receiving so many questions today. For east-west facing structures, how do you select the PV modules performance uh, to best fit on the ground for a 1 megawatt size of PV plant? Um, I'm a I don't I don't really like get quite what exactly is the question. But if you are trying to select which PV module as an equipment behaves the best with east-west facing structures, feel free to use our unlimited iterations and comparison tool. So instead of like doing designs between different MPPT or between different structures, use the same structure, same MPPT solution, but change your PV modules. And you can iterate as much as you want. Finally, you can compare the results in a comparison tool and see which one is the most optimized for your ground mounted 1 megawatt size of PV plants.
Of course, and also to add on that, I mean, you can also use our incredible database to select from many PV module manufacturers, powers, and configurations. I mean, for yourself, we have a very big and dynamic database which we update on a regular basis. So you can select from a wide range of manufacturers, as I said, power and all of that. So that's something that's going to be really useful to you when optimizing designs.
Yeah, perfect. And let me see if there are more questions.
Mm, mm. I don't think there's any more questions for now.
Any more new questions? No more. Yeah. Um, just for me to add one more comment on the bifacial comparison. If you're our users, feel free to also check that out on our platform to see how the results is varying. So from my observation to the design that I have shown you in today's presentation, we are getting less transposition irradiation on POA, of course, because of the GCR is higher for our east-west facing structures. But for all kinds of losses, either the ground reflection losses, ground shading of effects, far shading, near shading, IAM factor, all the losses that's added to our back face are lower, significantly lower for east-west facing structures. So that's why maybe for bifacial, if using east-west is also a good option. All right, perfect. So I think that's all. No more new. Yeah. Yes. If our software being utilized on rooftops smoothly, this question is actually already answered earlier. I said with our new layout editor, this is a new released feature. If you haven't seen it on your account yet, feel free to talk with your account executive so that we can make sure this
Yes,
feature is available for your account. And with that feature, you will find it much more smooth to develop rooftop projects as well. But I encourage you to try that out and let us know how you think of the results if it's meeting with what you're requiring or your design goals.
indeed.
All right. Perfect. Wonderful. I think we've answered all the questions. There were more
Yes.
than 10 questions, a lot. Thank you guys for staying so
Yeah.
keen until the last minute. Thank you.
Thank you all for being so active. We really love to see that.
Yep. All right.